Welcome guys to our special series of tutorials, where we'll demonstrate how to build a prototype from the idea to the actual device. We'll make the printed circuit board design using the Ideia software, and then we are going to produce the actual PCB. And finally, we'll solder the components, finishing our prototype. Let's get started. This is the first part of a series of 3 tutorials. Today, we'll assemble the circuit in the breadboard. The chosen circuit was the mini frequency generator because of its practical application and easy understanding. At the end of this tutorial, you'll be able to assemble your own frequency generator. The key part of our prototype is the IC555, famous among the designers and electronics lovers. Its fame may be associated with its easy usage and its ability to generate short and long timing, to not mention its low cost. It has numerous applications. Among them we mention the timer, the oscillator, the PWM generator, and the tachometer. Our prototype uses it as an oscillator. This is a pattern 555 oscillator configuration, known as S-table, where the frequency is given by the following relation. We will use a variation of this circuit by placing a potentiometer that will change the resistor-to ratio and thus the frequency. The inside of a 555 can be simplified in 2 voltage comparators connected to a flip-flop. The voltage reference of the first comparator is 2/3 of VCC and the second 1/3. When the voltage in the pin 6 is above 2/3 of VCC, the flip-flop output is high. When it is below 1/3 in the pin 2, the flip-flop output is low. The animation on the screen shows us how it works. Notice the oscillating square wave at the output. That's the feature we are looking for. This is the 555 layout. Please pay attention to the arrangement of the pins. A reference will be the notch, a round cut on the top of it. Material list is one IC555, a breadboard, a potentiometer of 100K, one 10 nanofarads capacitor, a 100 nanofarads capacitor, 2 resistors of 5K 6 ohms, 1 resistor of 1K ohm, jumper wires, and an LED. This is how your circuit should look like after the assembly, and this is the schematic made in the Ideia software. The first step is to locate the notch on the top of the IC and place it as shown in the video. Now connect one leg of 5K6 resistor to the pin 7 and the other leg to a whole distance from the IC. As you can see, now connect the other 5K6 resistor to the pin 7 and 8. Then connect the pin 8 to the VCC. Now we will connect the 10 nanofarads capacitor to the pin 5. One leg is placed in the pin 5 and the other leg is placed to the ground. Now, from the pin 6, we are going to go around the IC to connect the pin 6 to the pin 2, as you may see on the screen. Now connect the pin 4 to the VCC and the pin 1 to the ground. After doing this, we connect one leg of the 1K resistor to the pin 3 and the other to the positive leg of the LED, placed aside as the video shows. The other LED leg goes to the ground. Now we connect the 100 nanofarads capacitor by putting one leg at the pin 2 and the other leg in the ground. Connect the jumper wire with one tip to the pin 2 and the other distant from the IC, and another wire with one tip to the end of the previous one and the other 2 holes behind. Now a wire with one tip placed 2 holes ahead and the other tip towards the resistor connected to the pin 7. If you need, use an extra wire to connect them, as the video shows. Finally, it's time to place the potentiometer. The pin on the left side of the screen is being connected to the blue jumper wire. Thus, the potentiometer has a wire connected to each one of its 3 pins. Now we connect the grounds at the both ends of the breadboard, and we do the same with the VCC. And so we complete our circuit, as you can see in the comparison. Now we connect a VCC wire and a ground wire to connect the circuit to the power source. And then we are ready to test it. Our power source provides 12 volts DC. Now we connect the oscilloscope cable to the resistor leg connected at the pin 3 and the other tip of the cable to the ground, as shown in the image above. As you can see, a square wave was generated on the screen. Notice that by varying the potentiometer, we vary the wave frequency. This circuit is varying the frequency in a range nearly from 140 Hz to 1.9 kHz. If you want to, you can change the range by changing the resistor values or the potentiometer value, and so adapting this circuit to your project. That's it, guys. That was the circuit assembled in the breadboard. Do not miss the second part of this tutorial, where we are going to develop the PCB design in the Eagle software. To get more information, visit our social web at garagelab.com. To buy one of our products, go to garagelabstore.com/store. And don't forget to subscribe at our YouTube channel.